Welcome back to Crash Course Trigonometry. Today I'm going to be going over reference angles and converting from degrees to radians. So let's start off. What is a reference angle? Well, reference angles are acute angles that are formed with the x-axis and the terminal side of an angle. So they are always acute, they are always positive, and they always involve the x-axis. Those are the three criteria for an angle to be a reference angle. So say we have this random angle 495 degrees. Very out of nowhere, it's bigger than 360, there's other angles that equal it. One of the other angles that equals 495 degrees is 135 degrees. These are the exact same angle. This one's just a lot more complicated. But 135 degrees is not an acute angle, and so it's not a reference angle. Instead, the reference angle for both of these angles would be 45 degrees. It would be going positive from the x-axis right here to make the reference angle 45 degrees. Now, you might be saying, that looks like a negative angle, but with reference angles, it just isn't. It's a positive angle from the x-axis. So how does this help us? Well, if we look at the reference angle theorem, we can see how useful the reference angles can be. So the reference angle theorem states that a trigonometric function and its reference angle will differ only in whether they're positive or negative. So say we have the reference angle 30 degrees, and reference angles are denoted by a theta with a little caret on top of it. So say we have the reference angle 30 degrees. That could equal any of these four angles. It could be 30, 150, 210, or 330. But they're all the same, except for if they're positive or negative. So sine of 30 is 1/2, and sine of 150 is 1/2. Those are both positive. And sine of 210 is negative 1/2, and sine of 330 is negative 1/2, and both of those are negative. So instead of writing one of these, you could just write reference angle 30 and use your reference angle to help you find these. So say you know what 30 degrees equal, the sine of 30, you know that, but you don't know the sine of 330, then you can use the reference angle and just have to figure out if it's positive or negative. To find out if your answer is positive or negative, you can use the all students take calc trick again. All is in quadrant 1, students or sine is in quadrant 2, tangent or take is in quadrant 3, and calc or cosine is in quadrant 4. And we went over this in one of the past videos, so I'm not going to go too far into it. But you can see that angle 30 ends in all, so it's positive, and angle 150 ends in sine, and since it's sine, it's positive. And 210 and 330 are both negative because they are in the tangent and cosine spots, so they're both negative. So as you can see, reference angles can be very useful in trigonometry. You might not use them as much as you would think, but they're good to know, and you will definitely use them going forward in your math career. Next, I'm going to move into degrees and radians. So you've heard of degrees, it's what we've been using this entire time, theta in 45 degrees, it could be any type of degrees, and 360 degrees are in one circle. But there's another form of measurement, which is radians. 1 radian is 57.3 degrees, but that's just a confusing number. So we just use, radians is just another form of measurement. And it's actually the more standardized use of measurement. More people use radians than degrees because it's just easier to use and it's just smoother. So if we're converting from degrees to radians, we multiply the degrees by pi over 180. And if we are changing radians to degrees, we multiply the radians by 180 over pi. So example, if we have 90 degrees and we want it in radians, we multiply by pi over 180 and get pi halves radians. And all radians, involve pi. And there's 360 degrees in a circle, and there are 2 pi radians in a circle. And that's why for the circumference of a circle, the formula is 2 pi r, because there's 2 pi radians in a circle. So that's the basics of radians and degrees. You will definitely use radians in your future math career because that's what everyone uses. And yeah, we'll go more into degrees and radians in the next video when we talk about the unit circle and section 3.3. So there are some common degrees that we use in a lot of math problems. You know, we use 30s, 45s, and 60s a lot. So here are two charts that, you know, are the degrees and their radian counterparts. So 0 degrees is obviously 0 radians, 30 degrees is pi 6th radians, 45 degrees is pi 4th radians, and you can go through. I would, you know, pause the video, write these down, because these are very useful, and you'll definitely see them again, especially in the next video when I go over the unit circle, because the unit circle is a very important thing, and it uses these. So yeah, pause the video, write these down, make note of these. Other than that, that is the end of our video. So I hope you enjoyed watching, and I hope this helps you out a little bit. Have a great evening.